The average number of items a person buys from the store is hypothesized to be less than 37. A random sample of 13 customers is selected. Given that the curve is normally distributed with a population standard deviation of 30.9, using the p-value method, is there enough evidence to support the claim alpha is equal to 0.01? So we've given some data, and we're told to use the p-value method, which is nice because then we don't need to draw a chart. We can just look right at alpha. So no need to find critical values. And let's go ahead and do this thing. So we need to identify the null hypothesis, the alternative, and we need to identify what the claim is. So our null hypothesis is going to be H0, and that is that the mean, because here they're saying that the average of items a person buys from the store is hypothesized to be less than 37. But the null hypothesis we make equals to. So we're going to make this equals to 37. That's the default, that it actually is 37. The alternative is what we're suggesting, which would be that the null hypothesis that it's actually less than 37. 37 is too big. So that's our alternative hypothesis. Now the claim is the one that we're trying to say something about. Now we're hypothesizing that it's less than 37. So that's kind of the same thing as saying, can it be concluded? So the alternative is going to be the claim. So this one's the claim. We also know that since the inequality is a less than sign, that it's a one-tailed test and that it's left-tailed, because the error would occur on the less than side. So now let's go ahead and get the statistics from here. So we're given all these numbers, and we're going to go ahead and find what this is by using the calculator, because what we need is a sample mean. So we're going to grab the calculator. We're going to go into our list editing area and go ahead and clear out a list if there's stuff in it. And we're going to go ahead and put this in. So we've got 2, 5, 21, 21, 3, 37, 9, 80, 21, 3, 122, 24, and 49. And if we go back and double check this, 49, first make sure we've got 13 items, which we do, so that's good. 49, 24, 122, 3, 21, 80, 9, 37, 3, 21, 21, 5, and 2. Perfect. Now we're going to go into stat, go to calculate, and I'm going to use one var stats to get the numbers. Now you could just use the mean formula, but if you're going to use the calculator method, it's convenient to have them in a list. But first I'll show you doing it manually. Well, manually with using the calculator to get the mean. Make sure your list matches for your one var stats. Make sure frequency list is empty, and then hit calculate. We get a mean, an X bar, that's equal to, and my mouse is in the way, 30.54. Beautiful. We also know that the population standard deviation is 30.9. This tells us that we'll be using a z-test. And we're given n is 13. N is equal to 13. Is there anything else that we are going to need? We're given alpha right here. Alpha is 0.01. And I think that's all we're going to need for right now. Oh, we also need the population mean, which will be 37. So, okay. We're going to need to get our test stat to find the p-value. So that's going to be z. And remember, the formula is x bar minus the mean over the standard deviation divided by the square root of n. If we plug these numbers in, x bar is 30.54. We just calculated that. Minus the mean, which is the population mean, 37. We've got quite a large standard deviation at 30.9. And our square root of n is 13. Now let's go ahead, let's pop this in the calculator. So we're going to go ahead, go to the front. We'll quit this, and then we'll go type in a fraction, 30.54 minus 37 over, do another fraction here, 30.9 divided by the square root of 13. We do that, we get out a negative z-score of 0.754. Now you can get this same z-score using the calculator. If you go to stat, we go to tests, we're doing a z-test, and we are given data, so we choose the data option. Our mu naught is to be 37, so we put down 37. Our sigma is 30.9, it's right here, 30.9. The list 1 contains our data, make sure that matches. Leave frequency at 1, and then make sure this matches, which we have less than, and it's less than. And also make sure that you have the mean written on this side, because that's important to match up here. We're just saying that that this is mu naught essentially. In the calculator, it's got a mu 0, mu naught. So we're saying that mu naught, that it's actually less than 37. So if mu naught's 37, we're saying that our mean, the actual one that we think is actually less than it. So we choose that one. And then I like calculate because it gives you a more accurate p-value. You could also use draw, and it would draw the curve for you, so that's kind of cool. And we are given our p-value, and we look at that, we get the same z-score. So our p-value is equal to 0.2254. Now, if you wanted to find this p-value using the chart, you can. We would just look up the area that covers with a z-score of 0.754. So let's go ahead and go to the standard normal table for z stuff. We're going to go to 0.75. So here's negative 0.7. And then we're going to go over to, I can't see the top. 5 is right here. So we're going to just go across like this, up like that. So this is the one we're interested in. So the chart's going to be a little bit off because the chart has, it doesn't have every single value. The calculator calculates stuff. So we have 0.22663 for our p-value from the chart. And if we look at that, that's pretty close to what we have here, 0.22, and in this case, 54. So this is a little bit big, but that is going to be our p-value. So if you're using the chart, you would just look up the z-score and then take the area to the left of that curve, in this case, since we're doing a left-tailed test. So you see, you get the same thing. Now, coming back here, we do not need to draw a chart or find critical values since we're using the p-value method. So the p-value method, we compare p to alpha. If p is less than alpha, then we're in the shaded region, right? That would mean that our test stat landed in the shaded region because the p-value is an area, and that area is smaller than alpha, so it has to be in the alpha area, shaded region. So alpha is 0.01. So if we look at this, we say, well, 0.2 is greater than 0.0. So we say that the p is greater than the alpha. Therefore, do not reject the null hypothesis. Now, we say, therefore, do not reject because, right, if this was on a graph, alpha would be like this shaded region, but then the p-value is a bigger shaded region. And right, this is where the z-score that would go with it would be, so like negative 0.754. So we would say that, hey, our shaded region here is bigger than the alpha shaded region, right? This is the alpha shaded region, where the pink is the z-score, the p-value shaded region. And so we say it's bigger than alpha, so we can't be in it, which means we're in the do not reject territory. We're in the area that's not shaded by alpha. So because of this, we say, hey, we do not reject the null hypothesis. So now we got to say something about the claim. And so we have right here, we think the null hypothesis is true. We're not going to reject it because we think it's true. And so that means that our hypothesis, that the claim, which is right here, our alternative was our hypothesis, which was also our claim. So we do not have evidence to support this. So we would say there is not sufficient evidence. I don't know if I spelled that right or wrong. Sorry if I spelled it wrong. Evidence to support the claim. So you can say this. You might also say fail to reject H naught, because our aim was to, see if our hypothesis was true. So we were trying to reject H naught. I mean, ideally, I guess I'd want my guess to be true. That's why I think that it would be less than 37. But this is what you would do for a p-value. So p-value method's actually quite a bit faster, because you can just look directly at the values, compare them, and then make your conclusion instead of having to go through the chart and the critical values and all those extra things. So pretty nice way of very quickly coming to a conclusion without a chart. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.